Good day, guys. I hope we are all doing so well. So today, guys, let's analytical geometry grade 12. But before see a grade 12, let us do a revision of grade 11 work on it. So now analytical geometry, it talks about triangles, whatever that is in geometry, then it's here again in it. So we have a revision grade 11, and what you need to know before dwelling into grade 12 stuff, you ought to know and understand how to use these formulas and principles. Yeah. Now, the first one is distance, denoted by d, symbol d, is equal to the root sign of x2 minus x1 squared plus y2 minus y1 squared. Where does this coordinates comes from? We can say determine the length of line AB. Then A and B must have coordinates. So those coordinates, you're going to name them x1, y1, as long as they are in that order, x1, y1, for A, for B, x2, y2. Those are coordinates, and they must be in that order. Yeah, yes, guys. Then you will determine the distance between those 2 points. Then the next one is midpoint, denoted by M. Midpoint is the point between, it's the middle point between 2 other points on the side. Yeah, in the examination they will tell you point B or point C, the midpoint of line AB. They need to tell you, for you to apply this formula of midpoint, they need to tell you that. You cannot apply this formula without being told this particular point is indeed a midpoint of this line, and it's denoted by M, and M has got these are coordinates of the midpoint, xm, ym. These are coordinates of the midpoint. How do you find them? Using this formula, x1 plus x2 over 2 divided by 2, and y1 plus y2 divided by 2. Separately, we can find the coordinates, the x coordinate of the midpoint separately. We can find them also through this way separately. You can find of x through x1 plus x2 divided by 2, and for y, you're going to say y1 plus y2 over divided by 2. You can use this way or this one. It does not matter, but they're the same. Just that here they are separated. Here they are one thing, but here are separated. So it doesn't matter which one do you use and get. And guys, sometimes in the examination they can provide you with the coordinates of the midpoint, and you will say determine coordinates of maybe in line AB. C is the midpoint, then they will give you coordinates of C. Then they will say determine, then they will give you coordinates of B, then maybe the coordinates of A, they will not give you only one. They can say find the X or find P, the coordinates of A. So in A they can give you only one coordinate of Y, and they will say determine the other one through the use of midpoint. Then you're gonna just simplify and find the variable. I will show you as time goes on how do you go about that one. Then they've got parallel lines. Parallel lines, the gradients are equal. In parallel lines, the gradients are equal. Basically, if you have 2 lines that are parallel to one another, you must clearly and obviously conclude the gradient of these 2 lines are equal. Then you have perpendicular lines. Perpendicular lines wherein the gradient of those 2 lines, when you multiply them, they provide you with -1 as our answer. They compute you with -1 as our final answer. Basically, if you have 2 lines that are perpendicular to one another, they will say prove that this line is perpendicular to this line. How are we going to prove that? You need to find the gradient of this line first and find the gradient of this line after, and multiply these 2 gradients. If they give you -1, you will say therefore these 2 lines are perpendicular to one another. That's how you prove perpendicular lines in this concept. Then you have collinear points. Collinear points are 3 points on a line with the same or equal gradients. Then you are done with collinear. That's how you deal with collinear points. Yeah. Then now here today we're gonna deal again with inclination. You have dealt with this formulas in grade 11. Today now we're going to deal with inclination angle. How to find inclination angle. Grade 11 work. It's very important. Here's a question, guys. Determine the size of alpha and get the angle between line BD and AC. We have line AC and line BD. Line AC, line BD with coordinates. A is -5 and -2, C is 2 and 3, B is -1 and 4, then D are 6 and 3. Those are coordinates, and we have three angles: beta outside, alpha inside, then theta also inside of a triangle. This triangle, I hope you can see this triangle, guys. Hope you can see it there. Now we want to find this angle alpha here. Very simple, ne? How you gonna find alpha? Can you please pause the video and go through this example, guys, to refresh your mind of grade 11 work? Let me just, in the meantime, let me just remove on the side so that you can write. Ne? Please pause the video and go through that example. I'll be with you right now. Yes, guys, now let us continue with our example today. Ne? Now, how to find alpha here? Remember, guys, we have a triangle here. And the only way to find alpha in this case, remember, we're dealing with the angles and we have lines in this analytical geometry. There's to be some sort of gradients that needs to be found here. So one of the ways to find alpha is by saying, okay, since we're now in triangles, I learned that if we have an angle outside a triangle, that angle is equal to 2 times, is equal to the sum of the opposite interior angles of the triangle. That means the angle beta is equal to theta plus alpha. But right now we don't have beta, we don't have alpha, we don't have theta. How are we going to find those angles? Now, the easiest way to find these three angles. First thing first, let us find beta. Where is beta? Beta is an angle of inclination between our line BD and our x-axis. Now, I can find angle beta through the use of this line, through finding the gradient of this line. Remember, inclination talks about tan theta. Oh, guys, seems like my black color is finished. I don't know, but it's fine. So remember, in inclination, there is a formula we use. And in grade 11, we learned about this formula is tan beta is equals to beta for this angle. It does not matter which angle you use. If you want to write theta, you can write theta here. It's not a problem. Right now, we are finding beta. Hence, we use this formula. So this formula, we use it to find either the angle or the gradient. If and only if that line or the angle is on inclination, if and only if we are dealing with inclination angles, we use this formula to find angle beta and our gradient of any line, as long as it's on an incline. Now, we're going to use this line BD to find angle B through the use of gradient. Remember, M for gradient. Then BD, line BD, I can name this angles. I can say x1, y1, x2, y2. Basically, for D, -3 is my y2, then 4 is my y1. Remember, for gradient, we need that. Let us label our angles, our coordinates. Y2 is -3. -3 minus 4, all divided by 6 minus -1. I hope you understand what's happening here, guys. This is equal to -3 minus 4 is -7. -7 divided by 6 -1. 6 plus 1 is 7. So that means the answer is -1. Because of what? -3 minus 4 is -7 divided by negative times negative is positive. 6 plus 1 is 7. Then -7 divided by 7 is -1. Then we have our tan beta. Then our beta is equals to inverse of tan 1. Why do we say 1? Because we want this angle here. If you include this negative here, that means now you want to find this angle, and you don't need this angle. Okay? We want this angle. Hence, we want to say you exclude this one for now to make it positive. Okay? We don't deal with negative angles. Usually, we don't need to deal with negative angles. If we put that negative 1, that means we're going to find this angle here, and we want this angle, this full angle there. Now, what is tan 45 degrees? What is tan 45 degrees, guys? I mean, what is tan 1? I've already given you an answer. So it's 45 angle. But since well now there's negative included here, this 45 degree angle is for this angle here. But we want this full angle beta. You want to say 180 minus 45 is 135 degrees. That means angle beta is equals to 135 degree angle. I hope you can see it, guys. Yeah? Then I have my beta. I can find my theta again. See, where is theta? Here's my theta, guys. Theta is on this line AC. Remember, alpha is on line BD and angle line AC. Both the two lines, we found my alpha. But theta is only found on line AC. I can use the very same method to find theta. So I'm going to say tan theta is equals to m. The very same method again, x1, y1, x2, y2. Then y2 minus y1, x2 minus x1. That's gradient. That means y2 is negative 2 minus 3. Negative 2 minus 3. x2 is negative 5 minus 2. Negative 5 minus 2. Then negative 2 minus 3 is negative 5. Negative 5 minus 7 is negative 5 minus 2 is negative 7. That means we're going to have a positive 5 over 7. And then since well now we want to find theta, tan theta, you want to apply the inverse. So you have the inverse of tan 5 over 7. Then our answer is 35, 537.6 and so stuff. Remember, you don't run off early. So I have my beta and my theta. I can find my alpha through beta equal to alpha plus theta. Yes, that's how you're gonna find my. Therefore, my beta is equals to my alpha plus my theta. Why? Exterior angle of triangle. We are done. That's the reason we're gonna use. Then what is the beta? It's 135. What is my alpha? Is unknown. What is my theta? Is 35, 5376 degrees. Therefore, my alpha is, I'm going to transpose this 35 to the left hand side, or I can say 135 minus into 35, 5376. Then my answer is 99.46 degrees. Then I'm done with finding theta. That's how you find theta, guys. How are you gonna get it? So they will mark it properly. They will say, okay, you answer the reason. We found theta, we found beta. We substituted their values here and there, and so it's you're gonna get 1, 2, 3, 4, 5, 6, 6 marks, 6 over 6. That's how they're gonna mark it in the examination, guys. So please prepare yourself for such questions, because these questions they wanna appear now in June. Please, they wanna appear in the examination right now in June. Please prepare such questions when you practice. But these ones are very easy. Practice. Now let us go to the last example of our video before we come to the grade 12 work. Now, this is going to be the last example before we come to the concepts of grade 12, where we talk about circle. center, radius, those new stuff in grade 12. Ne? So I just wanted to remind you, these things are very easy, guys. Ne? You must not get shocked of whatever we're gonna deal with today for grade 12 work. Ne? Very easy stuff. Analytical geometry is very easy. It's very, very, very easy, guys. Simple and straightforward. Now let us do the last example. The last example, ne? The last example, it says ukuthi in the diagram, lines KV and OT are parallel. Line OT has the equation 3y minus 4x equal to 0, and k, coordinates of k is -2 and m. Here's the diagram here, guys. Here's the diagram. Here's the diagram, okay. Here is the diagram. We are given k here, -2 and m. We are given O here, which is 0 and 0 coordinates. We are given VT and KO. Yeah, I think this is the end. Now, number A. The question says, write down the gradient of the line passing through KV. Of the line passing through. Oh, you have theta here. Ne? Forgot there's an angle here. Theta. You have theta there. Now, guys, you want to find, or you just write down the gradient of the line passing through KV. Where is our KV there? Here's our KV. This line, KV. We want to find the gradient of this line. And these two lines are parallel, remember? And they say the equation of OT. OT is an equation which is 3y minus 4x equal to 0. Here's the equation of OT. Now, we have learned that if OT is parallel to KV, therefore the gradient of OT is equal to the gradient of KV. So this equation is equal to, is of OT, therefore this equation will also be of KV. Therefore I can find the gradient of KV through the use of this equation because of what? The parallel lines here, guys. Let us do that. Now we need to write it in the standard form for us to point out our gradient. We need to write in the standard form of y equal to mx plus c. We have learned about that. Let us do that. So you have 3y minus 4x equal to 0. Then our aim here is to find y. Y should be our subject of the formula in this case. So we have 3y is equals to -4 to the right is +4. Then you divide both sides by 3. Then y is equals to 4 over 3 x plus plus 0. It's not necessary to write this 0. It's not necessary to write this 0. Now, since now my equation is on a standard form, I can literally point out my gradient. What is my gradient? What is my gradient, guys? Therefore, the gradient of kind of line passing through KV is equals to 4 over 3. Remember, the standard equation of this lines is y equal to mx plus c. This is just our standard equation. Then this is how it looks. This is the same thing. These two are the same because m is our 4 over 3. When we have our x, then our c, it is 0. It's the same thing. Now m represents our gradient. You have learned about that in straight lines. Okay? M is our gradient, which is 4 over 3 here. That's why I wrote 4 over 3. You must not write x there. You must just write 4 over 3 as it is. This is our gradient for that line passing through KV. Okay? I hope you clearly understand why we use these ways to find out. Therefore, it's 4 over 3, 4 over 3. Those are our gradients of those two lines. Now let us go to the next question. The next question of this last activity for grade 11. Okay? I chose this question because it's so challenging. Not kakul but kanying. Number B. If the distance from K to the origin is 2,5 units. Find the value of m. Here's a question, guys. If the distance from K to origin is 2,5, it means the distance from K to origin is 2,5. Here, 2,5 units. And here, find the value of m. What is our m? Here's our m. Okay? And our m is on that line KO. Okay? And we are given the distance, so we can use the distance formula to find the value of m, the variable m. Okay? Very simple. So now, distance formula is called, so we are given the distance between K and O, which is 2,5. That means when I say 2,5, and here is equals to this root sign of x2 minus x1 squared plus y2 minus y1 squared. And here this equal to the square root of, you can label your coordinate here, y1, x2, y2. And here the result of our x2 is -2. And here -2. What is our x1? Is 0 squared plus y2 is m, then y1 minus 0 squared. And here is got 2,5. Then -2 minus 0 is -2. -2 squared, this value is 4. And here is 4 plus m minus 0 is m squared is m squared. 2,5. Now I need to remove this square root sign. I'm going to introduce squared on both sides. And here, then my answer is 2,5 squared is equals to 25 divided by 4. And here is equals to, remember this squared is going to remove this square root only, not anything under the square root sign will be removed or be changed. It will stay like that. 4 plus m squared. And here, then when I say 25 minus 4, what is the value of 25? What is the value of 25 minus 4, guys? 25 minus 4 is equal to 1,5. 25. Oh, it's minus here. Minus. I don't want to make mistake, guys. So yeah. So it's 25 minus. So it's 9 over 9 over 4 is equals to m squared. That means I've transposed my 4 to the left. Then the square root, remember you need to remove that squared on m. I want to say square root plus or minus. Therefore m is equals to plus or minus 1,5. Remember, our distance is not negative. So therefore m is equals to 1,5. Then I'm done. Done with finding answer. Then how are they gonna mark it in the examination? They're gonna mark you have substituted your values properly. You have introduced square roots on both sides. They're gonna give you 1 mark for that. They're gonna give you 1 mark for this. They're gonna give you 1 mark for your answer and your conclusion. 1, 2, 3, 4, 5, 6 marks for fair. Can you lose 6 marks, guys? No, you can't lose 6 marks. It's very, very important to have 6 marks. Now we have our m, which is 1,5. I'm gonna write it here. 1,5. 1,5. The last question for grade 11 work. The last but not least. Very simple and clear question. This one is very clear. Very challenging and clear. Very clear question, but challenging one. It's very challenging but clear. It's very clear, this one. This question is very, very, very clear, guys. Very clear. It requires you, everything is very clear, straight and forward. Now, the question says you go to number last and number C. Determine the value of theta. Determine the value of theta. How will you guys determine the value of theta? Seems like you cannot see it properly. Let me just write it here. C. Determine the value of theta. I hope you can see it, guys. Determine the value of theta. How can I find theta? Where is theta? Theta is this angle here. Is this angle theta? Now theta is not on an incline. Theta is not on an incline. So now, if theta is not on an incline, how are we gonna find theta? You're gonna use the concept of Fenton x-axis. Fenton x-axis, wherein we're gonna draw scattered line here. Can you see the Fenton x-axis there? That Fenton x-axis is very, very, very critical, guys. So our theta is being cut into halves, 2 halves. We have an angle between. We have an angle here. We have an angle again here, and we have another angle coming from the outside. Here we have this angle, not this one, not here. But this one is not important. This one outside angle here is not important. We have an outside angle here. This one, I can name this angle outside is. I can name it as. I can say it's. Sorry guys for. Let me just remove k here, but k is still there. So I'm gonna write our k. Remember, is -2 and 1,5. So I just want to show you how do you find our our theta. Then we have an angle outside here, yeah, this angle here. Yeah. So this angle is an outside angle, and we have two inside angle that forms theta. Yeah. Yes, guys. Now I can name those three angles. I can say this one, it can be A, this one can be B, and this one can be C, angle C. I hope you can see it, guys. Now, why do we do that? Because theta is not on an inclined, and I can only use A and B to find theta. I can add A plus B to give me theta. And that's how it's gonna work. I need to find angle A and angle B and add them together to give me theta. That's how you're gonna roll, guys. That's how you're gonna roll now. So, guys, let us find the value of theta. So the only way to find the value of theta, or one of the ways to find the value of theta, is by finding angle A and angle B. Yeah. Yes. Now let's check something. Angle B, it lies on our finishing x-axis. Yeah. It lies on our finishing x-axis and KV, line KV. That means I can find angle beta through this line KV. Yeah. So I can find angle B through that line. Yeah. Then that line gradient. Yeah. We have our gradient. We can find angle B. Angle B is equals to the inverse of that line. How much? So when I just say tan 4 divided by 3 is 53,1 dash 10 2. Remember, do not round off early. Then now I have my B. Yeah? I can find my A, angle A angle through the very same process. Tan A is equals to M. Yeah? Then we don't have the gradient of line. Angle A is an angle between our finishing x-axis and line KO. Yeah? Then we need to find the gradient of this line KO. We don't know the gradient of line KO, but we can find it properly. Yeah? So we can use x1, y1, x2, y2. Yeah? So gradient is 0 minus 1,5 divided by 0 minus -2. Then our answer is going to be 0 minus 1,5 divided by 2, and it's -3/4. Then it's tan A. Then therefore A is equals to, remember, don't put that negative. Let's not put that negative there. We don't deal with negative angles. Then my answer is 36,869,89765 degrees. That's how you find my A. Remember, guys, why do I not say 180 minus? Remember, this angle here, I'm gonna remove this negative. I did not put in this negative on my calculator to find angle A. So why don't I say 180 minus 36, since now I have negative angle here? It is because if I say 180 minus, I'll be finding this angle C, our obtuse angle. Remember, this angle here is our obtuse. Guys, that angle C is our obtuse angle. Hence, if I say 180 minus 36, it's going to give me 146. Therefore, that 146 is our angle C. That is an outside angle. But we need this acute angle inside or between this scattered line and KO. And that is an acute angle, which is equal to 36. It makes sense because it is an acute angle. So you don't say 180 minus, because if you say 180 minus, you'll be finding this angle outside here. But if you don't say 180 minus, if you leave it like that as tangent, inverse of tan 3 divided by 4. Then let me just write it like that, and like so that you can see it, so that you can see it. So it's going to be a is equals to inverse of tan positive 3/4. Then our angle A is equals to 36,86989765 degrees. That's how it is. And please guys, if you say 180 minus, you'll be finding this angle. Remember, in all space, you must make sure that you check good how the angle is placed. If it's placed like this, you can see this is an obtuse angle, and this obtuse angle cannot be equal to 36, it should be bigger than 90. But the angle here is smaller than 45. You can see it's an acute angle, or it's smaller than 90 degrees actually. It's an acute angle for A. So hence we say it's 36, this one. Then I can find theta by adding the two, angle B plus angle A. 53,13012 plus 36,8698 blah 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 blah. Okay guys, then just add the 253,130,102. then the answer is 89,9999990. Therefore you are done with finding angle theta. That's 90-degree angle there. I hope you can see it. And that's how you find angle C. Remember guys, another way to find finding this angle theta. Remember, if you can check our gradient, the gradient of this line KV is 4/3, and the gradient of line KO is negative 3/4. If you multiply the two, they're gonna give you -1. And remember, we talked about this concept. If you multiply two gradients and they give you -1, that means these two lines are perpendicular to one another. KV is perpendicular to KO. If and only if you multiply the two and they give you -1, that's another way of simplifying or finding the angle theta. Then we'll therefore conclude, therefore theta is equal to 90 degrees through this process of explaining what's happening there. Thank you guys. I hope you understand this part. We are coming for part 2, wherein we're going to explore circles in analytical geometry. Grade 12, we're getting to grade 12 stuff in the next session, part 2 of analytical geometry. Thank you very much. Enjoy your day. Okay. Introduction to circles. This is grade 12. Wait, guys. So let me just draw a partition plane here. And second is horrible. Then now here's a circle. This circle has got a center. I can name this center M. This center has got a distance, and it has got a length from center to circumference. We learned in cycle geometry, if you have a line from center to circumference, that line is our radius R. And our center has got coordinates in it. Our center has got coordinates of A and B. A for X, B for Y. Okay? Then our circumference also has got a point here. I can name it P, which is X and Y. Yeah, guys. I hope you understand what's happening here. So if you center and you have a line from center to circumference, it is our radius, and if a point on the circumference, you can call this point P, which has got coordinates of x and y. So you can literally find the distance from the center to the circumference through the use of distance formula. So any point of the circle's circumference will have r units away from the center. Basically, each and every point from center to circumference will have r units. Basically, will have the same length from here to here, from here to here, from here to here, from here. All these points from center will have the same radius or length. So now, how do you find the distance from M to P? That is going to be our basis today. How do you find the distance from this point, our circumference, to our center? Which one do we use? Remember, let's find the distance from M to P. Distance from M to P is equals to greater work. Distance would sine x2 minus x1 squared plus y2 minus y1 squared. Then now, from these, our x1 and our y1 are the coordinates of our center, and our x2 and y2 are the coordinates of our point on the circumference. I hope you can hear me. Let us substitute what we see on the diagram here. This is equal to root sine x2 is our x, x1 is our a, y2 is our y, y1 is our p. This is the distance of M and P. That's how you find the distance of MP. Since well now the distance from MP is r, distance from M to P is r length. Therefore, I'm going to substitute where I see distance from M to P. I'm going to say it's my r here is equals to root sine x minus a squared plus y minus b squared. Then I remove this root sine on both sides. I square on both sides. Squared. Now this squared will remove our square root. Be left with r squared is equals to x minus a squared plus y minus b. So this is the formula we're going to use to determine the distance or our radius of the circle. This is the formula we're going to use to find the radius, our radius of the circle. I hope you can see it, guys. So now you know your A's and B's are center, coordinates of the center, A and B. Then X and Y are just coordinates. X and Y are coordinates on the circle or circumference. Then our r is our radius of the circle. That's how they are labeled. I hope you understand what's happening here, guys. Now, there's an equation. This equation of a line is an equation of center. Okay, is an equation of any circle with center A and B with a radius r. So you can use this equation to find our radius and the equation of the circle. If the city must determine the equation of the circle, you must use this formula. You'll get the correct answer. I hope you understand what's happening here, guys. Let us do an example to clarify this issue very further. Yes. Now let me just remove here and get here. Let's do an example, guys. Number 1, determine the center and radius of the following. Number A, x minus 1 squared plus y plus 5 squared is equals to 12. Now we need to find the center and radius of this equation. Now we need to write, or we need to know if this equation is in the standard form. What is our standard form? X minus a squared plus y minus b squared is equals to r squared. Now if you can see this equation, our standard form is the same as this one. We just need to point out our center. What is our center here? Center is, remember, a and b are our coordinates of the center. 1 and 5, a and b are the same. But remember, when this negative 1 comes out of this bracket, changes the sign. Same applies to this positive 5. When it comes out of the bracket, change the sign. Or it follows our standard equation. It's negative here, it's negative here. If we divide negative by negative, is positive. Therefore, a positive 1 is 2. 5 positive divided by negative is negative, and have negative 5. Now, guys, remember here, then let's find our radius, which is r. Remember here we similarly have squared here, and we have r squared. Basically, our 12 here, we must make sure that we find r. Remember, we have r squared. Just like we have squared, and r squared. That means we have r squared here is equals to 12. And you square root on both sides, plus or minus. Square root plus or minus. Then our r is positive 12. Remember, distance cannot be negative. I hope you can see it, guys. That's how we do it. Neighbor, guys. That's how we do it. Then number B, we've got x squared plus y squared is equals to 25. How do you find the center and radius of this? Remember, we need to go back to our standard equation, which is x minus a squared plus y minus b squared. We should write this equation in this form. Let's write that in that form. You know that if you have nothing here on our x squared, if you do not have something similar to this here, that means the coordinates of our center are at origin. If you only x squared here or y squared, it means the coordinates of our center are at the origin. Remember, this equation on my left, or expression, is the same as this one. I can say x minus 0 is still as x squared. Y minus 0 is still as y squared. They're the same. I just wrote this equation in this form. Here it is. Now, what is the coordinates of our center? Coordinates of our center is this one, 0 and 0. What is our radius? Obviously, squared and r squared is equal to 25. Then you do square root on both sides, plus or minus. Then r is equal to positive 5. You are done. And it. Now we know good. Now we know good. Circles centered at the origin have an equation of x squared plus y squared is equal to r squared. Now this equation is of a circle centered at the origin. 0 is to 0. This equation to use, or this is an equation of a circle centered at the origin. So we have, when I have to deal with two centers, we have a circle with center that is not on the origin, and a circle with center at the origin. That's going to be our basis going forward. But this is our standard equation when determining the center and radius of the circle. So ungatideli guys, very simple work here. Let us do an example. Another example, the last one, for this part. Let me just remove number B. Number B, I'm removing it. Number C, we've got x squared plus y plus 1 squared is equals to 50. Now remember, you need to write this equation in this form. We only have x squared with nothing here. That means the coordinates of the center for these, they're not on the origin, since well now we got this y plus 1 on the left here, on the right here. Now remember, we have nothing here, x squared only. That means our center here is 0, is 2. Y plus 1 negative divided by positive is negative. That means we have negative 1. This is our center for this equation. Then r squared, we have is equal to 50. R squared is equal to 50. Square root on both sides, plus or minus. Then r is 5 times root of 2. Then we're done. I hope you understand what's happening here, guys. I hope you understand. Let us go to the next part of such examples. The next part of such examples. Next part of similar questions, but with weights now. We include weights. We include weights. And here now determine the equation of the following circles. We need to find the equation of the following circle. Number A, we have a circle at -2 and 1. This is our center with radius of 4. This is our r. Yeah? So we need to find the equation. Remember, we need to write our standard equation again. X minus a squared plus y minus b squared is equals to r squared. Now, these are coordinates of our center here. We need to substitute them on our standard equation. So where you see a, we put in 2. Where you see b, we put in 1. Simple. Let's do that. X, what is our a? Negative divided by negative. Negative divided by negative is positive. And if this -2 comes into the bracket, it changes the sign from negative to positive. Positive 2 squared plus, also with our positive 1 here, positive 1 divided by negative b. Our positive 1 divided by negative here is negative. And hence, if this positive 1 comes into inside the bracket, it changes the sign. -1 squared. This is our r4. Here's our r again. Then we have squared there, squared. Okay, guys. Therefore, our equation is equals to 16 x plus 2 squared plus y minus 1 squared. Here's our equation. You are done. I hope you can see it, guys. I hope you can clearly see number B. A circle centered at origin and diameter of square root of 10. How you want to simplify this one? Diameter. Remember, radius is the half of diameter here. Yes, then how our equation, our standard equation. X minus a squared plus y minus b squared is equals to r squared. Then centered at origin. Remember origin? Origin, you're gonna have x minus 0. Coordinates of our center are 0 and 0. Plus y minus 0 squared is equals to diameter. So we're gonna have something like this: square root of 10 divided by 2 squared. Why do we divide by 2 here? Because answer for our answer we have got if I have, let me just draw a line. If I have the length from, let me say this line AB here is our diameter and our radius is in the middle of here. That means I can say C here. The length from A to B, they say, is square root of 10. Now this is the length from C to B. You divide this square root of 10 by 2. It's going to give you the length of from C to B and from A to C. So diameter is, radius is our radius is the half of diameter. That means the length from A to C is the half of AB. Hence I divide by 2 here to find our radius. I hope you clearly understand me. Now the second equation is x squared plus y squared is equals to 10 over 4. Then you are done. I hope you clearly can hear me, guys. I hope you can clearly hear me. And now let us go to another part of our series of questions that are examinable. Remember, this is a basic, so you need to understand the basics here. How we do such things, the basics. You need to understand the basics here. Yes. Let's go to the next part of our questions. The next part of our questions. This is just part of introduction, guys. Yeah. This is part of our introduction. Determine the center and radius. Determine the center and radius. Number A, we have x squared plus 2x plus y squared minus 6y equal to 6. Now to determine the center here and our radius. How we want to determine the center? Remember, circle. If you want to see the circle here, we've got x squared and y squared. You can recognize the circle by squared, this squared, and here. Now I don't have full information. What can we do here? Guys? We have equal sign here, equal to 6. How are we going to find the center? Remember our standard equation again. We've got x minus a squared plus y minus b squared is equal to r squared. So do we have something like this here? No. How are we going to find our equation here? Remember, let me just simplify x minus a. If I can open brackets through FOIL, I'm going to have x squared minus ax minus ax plus a squared. Then I'm going to be left with x squared minus 2ax plus a squared. Now, guys, I hope you can see it. Our aim here is to have this kind of an expression. We're going to do the very same thing in here. I just want to come to this part and explain it using this one. You need to have something like this here. You need to have 3 expressions for x squared only. Leave out y squared plus minus 6y. Let's focus on x squared plus 2x. If you have something like this, we need more information. So you need to complete the square. Completion of the square. How do you complete the square? You divide your, and you remember, you divide your second term, 2x. And if you have 4 terms here, you will divide your second term for x squared and second term for y squared. 2x 6y. Your b, and remember, quadratic, a squared plus bx and plus c. Your bx, here's my b and here's my x. Here's my b and here's my variable. You divide your variable and you half and square it basically. So if you divide your variable, you divide it by 2, or half of your bx, half of your second term. So you're gonna have you open a bracket here. Open a bracket, x and plus, what is half of 2 is 1 squared. And remember, when you complete the square, you say plus 1 minus 1 and on the very same left side. But when you're going to take that, you're going to have you're going to have plus 1 and minus 1 and to balance the equation. But since well now you have equal sign here, if you had no equal sign, then you're going to leave it like this. But if you have equal sign, this negative one is going to come to the right side and have 6 plus 1 on our right. I hope you can see me. Then plus, we are done here. Come this one. What's the half of negative 6? Half of negative 6, negative 6 divided by 2 divided by negative 3. Very same thing, y minus 3. And here, y minus 3 and here. We're going to do the very same thing here. And here we said 2 divided by 1 is, 2 divided, half of 2 is 1, then 1 squared is 1 again. Then transpose this one to the right again. Same applies to this one. Negative 6 divided by 2 again. Okay. Negative 3. Then you square the very same negative 3 squared. Okay, 9. Then we're going to have negative 9 on our left. What you do on the left must also do on the right. If I transpose this negative 9 to the right, I'm going to have plus 9 here. This is how you complete the square. I hope you can see me what's happening here. So what's the formula to determine our equation is b over 2 divided by 2. What is our b here is 2 and 2 divided by 2 squared is 1 squared equal to 1. Is our 1. That's how we determine, that's how we complete a square if you have an equation, guys. Please, I hope you can hear me. Now 6 plus 1 is 7 again. 7 plus 6 is 16. Then we have x plus 1 squared plus y minus 3 squared. Then center is, remember, surely you have already mastering it. This one here. Center is negative 1 and 3 here. Then our radius is radius squared here is equals to 16. Then square root on both sides, plus or minus. Then our r is equals to, what is square root of 16 is 4. Then we are done. That's how we determine our equation. Then let us do an example that is similar to this one. Here's an example, very similar example. Number B. Number B, we have 3x squared plus 12x plus 3y squared plus 6y is equals to 2. Determine the center and radius. Basically the equation again. First, you need to find the equation. You must write this equation in our form of, in this form again. Now remember, if you have something like this here, we have no information, we have no full information for this one. Therefore you complete the square again. How do you complete the square? Your squared coefficient with squared needs to be positive 1. Not right now. If we have check x squared has got 3, if check y squared has got 3. Now you need to divide each and every term by that number. And here you need to divide each and every term by that number before you can do anything here. Now divide both sides by each term by 3 here. 3 3 3 3 3 here. 3 is our common factor. 3 is our common factor and here. Or just divide by 3 on both sides. So only if you check only your squared or what do they have there? Here. Then you want to be left with x squared 12 divided by 3 4x y 3 divided by 3 is y squared plus 2y equal to 2 over 3. Your aim here is to have only your coefficients of x squared and y squared to be equal to 1. That's our aim. So you need to divide by any term, as long as that term, when you divide your x squared and y squared, be both the x squared and y squared, their coefficients equal to 1. Therefore you're correct. Let us simplify this one. Composition of square. Surely you already mastered it. X and 4 divided half of 4. Half, what is half of 4? 2. 2 squared 4. So we have plus, and here is half of 4. Okay, get 2. Half of 4 get 2. Sharp. Then 2 squared get plus minus 4. And here is plus and minus, and so we're gonna have minus 4 here on my left. But if you go to the right, you're gonna have 2 over 3 plus 4. Hope you understand. Plus y, half of 2, 1. 1 squared, 1. negative 1 on the left, positive 1 on the right. Hope you can listen to me. 2 over 3 plus 4 plus 1 is 17 over 3. And then you have your x squared, your x plus 2 squared plus y plus 1 squared. Center is negative 2 and negative 1. Radius r squared is equals to 17 over 3. Square root on both sides, plus or minus r. Therefore, your r is equals to the square root of 17 over 3. Then you're done. I hope you can listen to me. I hope you can hear me, guys. I hope you can clearly hear me. Let's do number C. So, guys, number C. Number C. So simple, ne? So number C, we have x squared plus y squared minus 3y minus 4 legally 0. Now we need to find, remember, we need to find the center and the radius. We need to find the center from radius, but we have x squared plus y squared minus 3y minus 4. Yeah. So now, in this case, we don't need this constant on our left. We just need to transpose to the right. You only need to be left with, so that we can complete a square. Yeah. So we're gonna have x squared plus y squared minus 3y equal to 4. We're left with this on our left. Now for x squared, you know what, if you have nothing here, if you have no coefficient of x, if you can look at x squared only, there's no coefficient here. Therefore, you don't need to go through the process of completing the square. We only have x minus 0 here, squared. Then this is 0. And here you're going to have 4 plus 0 here. 0 divided by 0 is 0. 0 squared is 0. Add it on the left, on the right here. Plus y. Can you divide that? Oh, it's 8 here, not 3. It's 8 here. It's 8. So guys, it's 8 here. 8. So negative 8 divided by 2, or half of negative 8 is negative 4. Yeah. Squared. Then half of negative 8 is negative 4. Negative 4 squared is 16. Then you add it on the right. I hope you can hear me, guys. Now we have this equals to 20. X minus 0 squared plus y minus 4 squared. Yeah. Center 0 and 4. Yeah. Radius r squared here 20. Then square root on both sides. So r is, what is the square root of 20? It's 2 and square root of 5. Then we're done with number C. Then perhaps the last one, number D. Number D, we have x squared plus y squared minus 8x equal to 20 minus 2y. Now this one is, it seems like it's horrible. This one, it seems like it is horrible. So we have x squared. Sorry for the light, guys. Sorry for the circle there, the light with the circle with light there. I hope we can see we've got x squared. Next to D we have x squared plus y squared minus 8x equal to 20 minus 2y. Yes. Now in this case we see horribility here. So guys, since well now we've got body negative 8 or x and 2y, just group them according to their variables, similar variables. So x squared goes with negative 8x, y squared goes with 2y. Let's do that. Let's transpose whatever is on the right to the left hand here. So we're going to have x squared minus 8x here plus, we are done with x here. We're going to come into the y's. Y squared plus 2y here. This 20 is a constant, you leave it on the right, equal to 20. Complete the square from this. Open the bracket, x here. What is the half of negative 8? What's half of negative 8? Negative 4. Negative 4 squared, positive 16. 20 plus 16 plus, what is half of 2? 1. 1 squared, 1 plus 1. Okay. Then we have x minus 4 squared plus y plus 1 squared equal to 20 plus 16, 36. And 36 plus 1 is 37. And then center 4 and negative 1. Radius, remember, is r squared. And 37 square root on both sides, plus or minus. Then what is r is the square root of 37. Then you are done. I hope you can see it, guys. Then the last part of our questioning, so I think this one the last part of our questioning, I think this one is very simple. It's examinable, this one, very examinable. Please pay attention. This one is very examinable. This question is very examinable. They will ask you in the exam. Definitely. They will ask you this question in the exam. They will ask you this question in the examination. Determine the equation of the circle whereas a diameter CD with coordinates of C as 2 and negative 1, and your D as negative 6 and 7. Now, here's our diagram. Okay. Is our center. So basically is our center. Horrible, guys. So here's our center. I think, yeah. But guys, you can see that this is a straight line here. This is a straight line. And here C is 2 and negative 1. Then your D is negative 6 and 7. Now you need to find the equation. So the equation obviously is the same as x minus a squared plus y minus b squared equal to r squared. So we can find a and b, coordinates of our center here. How can we find our coordinates of our center? Remember, they told you that this is our center here. They have shown you on the diagram. This is our center. If you have center, we use midpoint equation to find coordinates of our center here. We are given the coordinates of D and C. You can find the coordinates of our center, and here, which is center M. Usually, center M. How are we gonna find coordinates of center M? Remember, x1 plus y1. X1 plus x2 divided by 2, and y1 plus y2 divided by 2. Now you can name your coordinates here: x1 y1, x2 y2. And what is our x1 is 2, what is our x2 plus negative 6, all divided by 2, and what is our y1 is negative 1, what is our y2 is plus 7 divided by 2, then 2 minus 6 is negative 3, negative 4, and negative 4 divided by 2 is negative 2, and 7 minus 1 is 6, 6 divided by 2 is 3. Therefore, these are our coordinates of our M, or our center. I hope you can see it, guys. I hope you can see it. Now let us write our coordinates again. Our coordinates is we've got x, it comes inside the bracket is plus 2, it comes inside the bracket is y minus 3 squared is equal to r squared. You don't have r squared. How can you find r squared? We use any of the two to plug them where you see x and y to find r squared. Any of the two, c and g. So let us use c, coordinates of c, and we plug where you see x, we put in 2, where you see y, put in negative 1, or we can use coordinates of d, it's not a problem. So we have 2 plus 2 squared, plus y is negative 1 minus 3 squared equal to r squared. Then 2 plus 2 squared is 4. 16 plus 16 is 32. So you have 32 equal to r squared. So there's no need for us to find specifically r, not r squared, because already our equation is r squared. So let's leave it like this: 32 equal to r squared. Then our basic equation, therefore, we have x plus 2 squared plus y minus 3 squared equal to 32. Then this is our equation. We are done. I hope you can hear me, guys. I hope you can clearly hear me. I hope you can clearly hear me. Now let us do the last examinable part, or let us do an examinable question here. A very simple one, wherein we find the variables. We do the last part of our question here before we go to tangent. Our last part, which is number B of examinable question. The equation of the circle x squared plus y squared minus 4x plus 6y plus k equal to 0. Now this equation has a radius of 7. Determine the value of k. How do you gonna find k, guys? K. Now the first thing first, you should put your equation in a standard form here, in this form. If you have something like this, if you have an equation with coefficients here, if you have this, if you have equation with x and y to power 1 again, x to power 1, y to power 1 with their coefficients, and we have x squared and y squared here, you complete the square here. Simple. Let's do that. So we arranged it into order: x squared minus 4x plus y squared plus 6y, and here this k is a constant, take it to the left, and here equal to negative k. Therefore determine the completion of square here, completion of square here. Hurry, surely you must type negative 4, half of negative 4 negative 2 and half of negative 4 negative 2 and then negative 2 squared is positive 4 negative k plus 4 and plus half of 6 positive 3 squared positive 9. I hope we can see it, guys. Then now here's our equation. Remember, we want to find k and remember this equation on our right is our r squared and I hope you can see me and remember we are getting the value of the radius, which is 7 and that means our r is 7 and our r, but we have r squared and on the right r squared and is equals to this negative k plus 4 plus 9. Basically our r squared is equals to negative k plus 4 plus 9. What is our r? 7, but since we have squared 7 squared equal to negative k plus 9 plus 4. I hope you can hear me. Now let's find k here. Therefore we're going to use this equation to find k and then we're going to have a negative k plus 13 is equals to 49. Therefore k constant to constant and we're going to have k 49 minus 16 minus 13 is 36. That's how we find k. I hope you can hear me, guys, on this one. I hope you can clearly hear me. That's how we simplify this question. That's how we simplify this type of question. Yes. Now, let's go to the last part of our questions. The last part of our questions. The last part of our questions, guys. Tangent to a circle. Tangent to a circle. Tangent to a circle. Now if you can draw my circle here. And this circle of mine has got a line that touches it at one point. That line is called a tangent. And then we have a center here. We have a center. And if you have a line that touches the two circumferences and has got a center, it's our diameter. So here's our diameter. And what is the half of a diameter? Basically a line from center to the circumference is our radius. Yeah. Then obviously this is our chord. Yeah. If you have a line from one circumference to another, is our chord. It's our chord. And if another line that touches the circle at 2 points, this line is our secant. So we're going to learn about this concept going forward. We're going to learn about this concept going forward. Now let's come back to the theorem. Our theorem 9. Our theorem 8 in circular geometry. If we have a circle with a line that touches it at one point, I hope you can see this line, guys. I've drawn a horrible circle here, but it's fine. I hope you can see. I think I've drawn a horrible circle. Let me just move this one. Just draw a proper one. Here's a proper. No. guys. But I hope you can see it. Then you have a center and this. So if you have a line from center to if you have a line that touches from center to our tangent, and this is our tangent, and you have a line from center to our circumference, that line is called our radius. So if you have a radius that touches our tangent, if you have a radius that touches our tangent, therefore this angle here is equal to 90 degrees. Why? According to theorem, tangent tan perpendicular to radius. What does this mean? It means to go to the radius. If this is the case, then the gradient of our radius, which is r, when you multiply it by the gradient of our tangent tan, is equal to -1. Because of tangent perpendicular to radius. That's where this concept of multiplying tangents being equal to -1 comes. It comes from this theorem 8 of our circle geometry. I hope we can see it, guys. Now, first question, number A. Number A, it says that determine the equation of the tangent to x squared minus 2x plus y squared plus 4y equal to 5 at this point, -2 and -1. We need to determine the equation of the tangent of this. How to determine the equation of the tangent? For us to determine the equation of the tangent, we need to know the equation of determine the equation of the tangent to the circle with this at this point. Now, to know the coordinates, before we can determine the coordinates of our tangent, we need to find the coordinates of our center. Now, if you have this equation, we're going to therefore complete the square. Let us complete the square. So we have x squared. What is the half of -2? No, excuse guys. What is the half of -2? -2 divided by 2 is -1 squared. Remember, -1 squared, +1, 5 plus 1, plus y. What is the half of 4? 2 plus 2. 2 squared is +4. Then obviously we've got the coordinates there. X minus 1 squared plus y plus 2 squared is equals to 5 plus 1 is 6, 6 plus 1 is 6, 1 plus 1 is 10. Now center, its coordinates are 1 and -2. Now we need to find the equation of a tangent. Remember, tangent is a line, it's a straight line. Therefore, our tangent, its equation is y equal to mx plus c. That's how you find the equation of our tangent. It's a straight line, and hence you say we need to find mx plus c, the equation of a tangent. Hence we resorted to finding the center first. Let us remember, we are given the coordinates at this point, which is -2 and -1, and it's our center, which is 1 and -2. Let me just remove this one. So we need to find the coordinates of our center here. Let me just draw this scenario here, guys. Let me just draw this scenario. So the circle, our center is 1 and negative 2, and 1 and negative 2. That means we've got something like this: 1 and negative 2. Guys, yes, I think this is fair. 1 and negative 2, and our, remember, this is our x, and this is our y, x, y. So for this point, we have negative 2 and negative 1. That means the coordinate of y, which is negative 2, let's see, will be positioned in the same point, and in the same line, the horizontal line. So negative 2 for x is negative 2, and then negative 1. So you have them like this here. They're going to be positioned like this, and negative 2 and negative 1, then 1 and negative 2. That is retransformation. They reflect on one another. Yes, hence you have them like that. So you have a center here, and this is our center, which is 1 and negative 2, and you have a point given, which is negative 2 and negative 1. Now what do we want here? We want the equation of the tangent. Where's our tangent? Our tangent is here. Oh, guys, but I hope you can see our tangent there. So here's our tangent here. Guys, can't draw a proper line here, but I think you can see it, guys. It's fair. I hope you can see it. Sorry for the light there that you cannot maybe literally see it. Now, how do we find the equation of our tangent here? Remember, to find the equation of tangent, you need to find the gradient of our line there. What is our gradient? We need to find the gradient of this line. How do you find the gradient? Gradient of our radius, and this line, our radius. Gradient of our radius is equals to x1, y1, x2, y2, and x1, y1, x2, y2. So negative 2 minus negative 1, and x1, y1, x2, y2, and divided by 1 minus negative 2. Then negative 2 divided by 1 is 1, and negative 2 plus 1 is negative 1. Then you should put this on a calculator when I have negative 1 over 3. And remember, we said that the gradient of our radius, when you multiply with the gradient of our tangent, is equal to negative 1. And so the gradient of our radius multiplied by the gradient of our tangent is equal to negative 1. Therefore, when I have negative 1 over 3 multiplied by the gradient of our tangent, we need to find the gradient of the tangent. And we need to find the gradient of our tangent. So the gradient of our tangent is equals to, you divide both sides by negative 1 over 3, you're going to get 3. This is our gradient. This is our gradient of our tangent. Therefore, we have y is equals to 3x plus c. Now we're going to use any point from our circle. As long as that point touches the circumference, which is this point. This is another point that was given on the circle, which is negative 2 and negative 1. We're going to plug these coordinates here on this equation to find c. So we have x and y, negative 1, which is our y, equal to 3. Our x is negative 2 plus c. Then what is our c? Our c is equals to 3 times negative 2 is negative 5. Then I'm going to transpose that negative 1 to the left. Is going to have I think we're gonna have 5 there. So we're gonna have 3 times negative 2 is negative 6, and so we're gonna have negative 6. Hey guys, don't know what's happening here. So we have negative 1. 3 times negative 2 is negative 6, and so we transpose this negative 6 to the left. Is gonna have positive 6 equal to c, and therefore c is equals to 6 minus 1 is 5. This is our equation. Therefore y is equals to 3x plus plus 5. Then we're done with finding the equation of our tangent. That's how you find the equation of our tangent. And then now we are done, guys, for remember, let me just talk about transformation before I close. Transformation very fast, briefly. Let me just talk about transformation briefly. Transformation, simple, so you need those full marks in the examination. Let's talk about transformation. Transformation, guys. Transformation. Now, transformation. Translation or transformation. Transformation. Remember, transformation only deals with your center. Transformation, we only talk about center here. Center A and B. So when you say 2 units to the right, talk about your center. Yeah. So for an example, if you have an equation here, x minus 1 squared plus y plus 2 squared equal to 5. So this equation is translated 3 units right, and 3 units right and 2 units down. And here, now determine the new equation. Determine the new equation. So that's for the writing there. So it's English is never loved us. Translated 3 units right and 2 units down. Determine the new equation. So this translation only affects the center. So now, so guys, our center, the coordinates of our center is 1 and negative 2. Hope you can see it. Yeah. So if the coordinates of our center is 1 and negative 2, they say 1 here, 3 units to the right. 3 units to the right. That means, remember, if you have a draw my collision plane here and plot this point, we're going to have 1 and negative 2 here. Here's our 1. And here's our 1. So when I have 1 and here's our 1. 3 units to the right, we talk about our x. 2, 3, 4. 1, 2, 3 units to the right. That means we have 4. Then negative 2, they talk about negative 2, which is 2 units downwards. Negative 2. Here's our negative 2. Negative 3, negative 4. 1, 2 units to the right, downwards. That means we're going to have a new center here. A new center will be 4 here and negative 4. That's how we write that's how we translate here. So 1, 3 units to the right, 2 units downwards. Then our new equation is x. Remember, x, it comes inside the bracket, and here it's going to have negative 4 squared plus negative 4 comes inside the bracket, positive 4 squared is equals to 5. Then you're done. You are literally done with that one. Thank you very much, guys, for your time. I hope you have enjoyed the lesson. In the next session, when I deal with different and various questions, let us meet on WhatsApp for more questions and answers, for more clarity on this lesson. Ngiyabonga, kalebo. Thank you very much.